Welcome everybody to July 2022's SVPMA meeting. And tonight we're pleased to have with us Ryan Withop. And he has spent his career dealing with data science and artificial intelligence and a lot of things surrounding analytics, which is a key technology that drives a lot of products here in Silicon Valley. So we're all looking forward to hearing what Ryan has to say and things that he's learned, everything from electronic arts up through RingCentral is his most recent. He's got quite a lot of interesting things to say around artificial intelligence. Just a quick aside that we had in the green room before we started, I was mentioning that one of the venture capital execs that I was chatting with was commenting a couple of years ago that it seemed like all the startups that were inventing new products were trying to sprinkle a little bit of AI pixie dust across everything in order to get their product up to the next level. And so that's one of the things that Ryan will talk about, the pitfalls of that pixie dust and where that leaves us today. So with that, Ryan, take it away.
Yeah, thank you, Tom. I appreciate you guys giving me the opportunity to speak with you all as well. I don't always get invited to product management things here, being an analytics guy, but actually I'm now within a product management organization, so I think I can properly be received here. Before getting into the presentation, I thought we'd start out with something that's probably a lot more interesting than me. It's just sports cars crashing. This is comedian, what's his name? Eddie Griffin, and he is crashing a very rare Ferrari. It's a Ferrari Enzo. There's about 300 or 400 of these, and yeah, he crashed it at a charity event several years ago. And I thought this was apropos because people think they can just jump into a performance car without ever having sort of worked their way up. And actually, I feel the same thing is happening with all the press that's around AI. People think, hey, let's jump into AI. Let's hire data scientists as our first analytics person. And really, you need to work your way up to that level of performance. As Tom mentioned, I'm the director of analytics and product growth within RingCentral. I just joined a few months ago. I'll tell you a little bit about why I did that. Some background: RingCentral is basically a way to work in the hybrid world. I can receive phone calls from work right here on my cell phone. I can text customers or vendors, receive internal messaging like Slack, so for writing employees, and also do video calls. And I thought it was a really good example of AI, and it was one of the main reasons why I joined the company, was I thought they were doing something really novel. And what I'm showing here, it might be a little choppy for animation across Zoom, but this is a video meeting, and we're using AI to actually transcribe what is said in the meeting and turn it into a little summary. And there are also topics and keywords that I can click. So if I missed the meeting and I got this recording, I can jump right to the spot that I'm actually interested in and skip that full 1 hour of stuff that I didn't want to hear in the first place. And then it's also showing that it records who said what. So if I saw something of interest, I can click right on that person right at that spot, and then we'll jump into that. Something I saw today that actually Tom had mentioned, so perfect segue. That's really cool. There's some really unusual uses of AI, and this one is the Dolly. This is Dolly Mini, so it's based on the Dolly thing that Tom mentioned, and it's just a better interface for typing in something random you want to see, like what if scientists sent a Roomba to the bottom of the Mariana Trench, and it generates these images combining those key items into a bunch of variations for you. So it generates a lot of really unusual artwork. So this is what I'm going to go over today, but before we do that, I just want to get a sense of who's in the room. So I'm hoping you can go to the reactions part of Zoom. You might have to click on your Zoom window to bring up something from the bottom there. You'll see reactions. And if you're on mobile, you might have to click on the 3-dot sort of more button to get to reactions. But if you could give me the clapping icon, if you work in digital products like apps and internet services, and hopefully I'm able to see that somewhere. See Tom, Dan there. Okay, a few more. We got money sign. I'm not even sure. All right. Maybe clap your hands for reaction if you work in physical products, consumer products. Let's see, what other products might we have? How about data products? One trend that I've been noticing recently is product managers are getting jobs strictly to do back-end work and manage data engineering flows. All right, and if there's any other industry that I didn't mention, feel free to type it in the chat there. What you didn't know is unbeknownst to you, I managed to get myself a round of applause before I even did anything at all. So thank you to the digital world for enabling that. What I want to talk about today is a machine learning project that I ran at WeVideo and give you some insights to the basics of actually doing this yourself. So the processes and tools that we use to do it, and some lessons learned, because I'm going to give you a little advance notice. It failed miserably. And then at the end, we'll do some questions. I'll be happy to answer any questions you have. Hopefully it turns into a discussion. I know that's sometimes harder over Zoom, but if you could either hold your verbal questions to the end, or feel free to write them into that chat window, and Tom will help me at the end of the meeting kind of read out those main things, and happy to go through it then. So I wanted to, before even getting into things, really address the elephant in the room here, and that is the terminology. You've already seen me use the term AI, and I've used machine learning now, and there's a bunch of other ones that the press has been throwing around, and the terminology has really been shifting over time. So I thought I would define it and differentiate, even though the press isn't really differentiating. You can sound a bit smarter at work, I suppose, by knowing the difference here. Artificial intelligence really started as a means of using computer programming to duplicate human intelligence or assist humans, and kind of act in a human way. And artificial intelligence in the last decade or so has at least expanded the way people are talking about it now to be more about using computers to learn and solve problems and recognize patterns. There's still an element of that, gosh, we wish it would be like a human to it. But you probably noticed that this is a larger data set of types of problems that we're solving now. Nectarios had an interesting way of separating out these terms. So AI is now being used kind of as the umbrella for all these different terms. I like to think of it in a slightly different way. So while machine learning is really a subset of artificial intelligence now, I would claim that predictive analytics is a piece of machine learning. Deep learning is something very, very different that most of us probably won't have to delve too deep into, but it's really hot right now. And so I separate these two out here, but they are really pieces of machine learning. The way the definition works is it just really comes down to which model are you using, and is that model classified as a predictive analytics model, or is it a deep learning or a machine learning model? To help us differentiate this, though, I like to think of AI as, it's Siri, it's chatbots, it's self-driving cars. And what differentiates it from machine learning is typically the programming is trying to weigh multiple possible outcomes and decisions, whereas machine learning tends to be more singularly focused on providing a recommendation. So that red chart on the right, maybe we are predicting a price that something like the airline flight would be. And that left plot, the classification, maybe we're trying to determine does someone have cancer or not. So a single set of predictions. And defining the term data science, those are the people that are really building the model. Whereas these days, when you look at job openings, machine learning tends to be more about the people who are operationalizing that, moving the data, keeping everything running in the cloud such that you can get predictions back. I'd like to give us a preface on WeVideo because that's going to be the example that I'm using in my frame of reference here. So WeVideo, I was the director of analytics and data science just a few months ago, in fact, and we are the #1 online video editor in the world. There's over 30 million users, and it all happens through the browser, so there's no software to download. So typically, either schools or small businesses who want to promote themselves on Instagram would, type in wevideo.com. They might upload their content and choose one of these templates to professionalize their content and create a final video for social media. One of the projects we had, it was actually determining what templates are appropriate for what users. So we're doing some predictive analytics there. In addition to using a template, there is a full-blown editor, so you could take every one of your clips and images and actually move them exactly where you want them to be. And this is a fully online product, so it's a freemium subscription model. So there's a bunch of paid plans, and many people also sign up for free. And when their usage goes over the limit, maybe they're uploading lots of files, producing lots of videos, or they're starting to use one of the features that's more professional in nature and has cost associated with it, like using stock, they might move up to these different plans. I'm talking mostly about machine learning from this point on, and we'll come back to AI towards the end. But as you see, there's a lot of different possible uses for machine learning. There's many I'm not showing here. Interestingly enough, Uber and Lyft, they do all sorts of predicting best routes for their drivers, and they know where you are within, I think it's a few seconds if you're a driver. So it's really interesting work that they're doing. The questions that I was trying to answer with this particular project at WeVideo was, all right, who are those free users is going to buy? And what plan are they going to buy? And we also did a model of who's going to retain versus who's going to churn. And what we want to do with that is get a prediction out here of their likelihood, let's say, to buy, and send that to our email systems and our in-app notifications in order to influence those people who are on the fence by using those communication methods to help them towards a purchase. The approach that I took here was I was looking for a single vendor who could handle everything from the data movement all the way through the serving predictions, end to end. And I was looking for someone who could also provide a machine learning partner for us, as the company did not yet have data science capabilities in the house. There's a lot of different services here. We happen to choose Google Cloud for this particular project. I'm going to assume that this crowd is less familiar with the actual process. So I'm going to outline what it takes to produce either predictive analytics model or machine learning models. And really, so this is a standardized process that we use in data science. Really, it starts with understanding the levers behind your business. What would cause somebody, in our case with WeVideo, to actually need to purchase? And then digging into the data itself, how are we actually tracking that information about what people are doing in the application? What does it look like when you actually look at the tables? Where is the data? The data preparation piece is about cleaning the data itself and preparing it for, we basically have to translate it into something that predictive engines can use and mathematical modeling can use. Then we model it, we check to see whether it's doing what we want it to, and we make it available in production for digital apps. But something that they don't really tell you is 80% of a data scientist's work is actually in preparing the data. The modeling is fairly easy. It's mostly about, gosh, the data isn't what I thought it was, and how do I get it into a form where I'm not biasing the predictive modeling? The other piece they don't tell you is there's actually a whole nother process that isn't shown in this screen. And so I'm going to talk about that as well. This is what a data set might have looked like at WeVideo. Obviously, I faked it here, and obviously WeVideo and RingCentral, are not, I'm not representing their views here. These are mine. But here's an example data structure that might come out of a tool like Amplitude Analytics or Mixpanel, pretty popular tools among analysts and product managers. So every row of this table is an event, and it's associated with a user ID. And then every column is a property specific to that event. So in this first case, we're looking at, I have one user who's got multiple events here in my table, but related to uploading a file, this is the file type and the length and so forth. And what you see is that the other events might not have a value for that property because it might not be relevant to that. Another thing you see is here I have a user who's moving a clip in that timeline that I showed you, and we wanted to know whether they had a logo on their clip. But you see in another event, we're tracking it a completely different way. And so this is data that I'm going to have to clean up later, once I've actually seen it. On the far right is my target column. So since this is historical data, I know who has purchased and who has not. So those who have purchased are 1, and those who have not purchased are 0 in this case. Generally speaking, this is what the process looks like. We take this historical data, clean it up. We apply multiple mathematical models to it, figure out which mathematical model is doing the best job at using these different columns or properties to figure out, to predict whether the person had paid or not. The output of that becomes our prediction API or prediction engine. And we're going to send it new data. We don't know who has purchased and who has not. And it's going to spit out a prediction. So to get there, that sounded really easy, but actually to get there involves 6 different cloud services. And at the highest level, what we're doing is scheduling a job to pull in the data, clean it up, and prep it for prediction and pump that out. I'm not going to go into a lot of detail as to each particular function here. I just mostly wanted you to see what it looks like. Here's what it actually looks like in the Google Cloud platform. It might be hard for some of you to read, but these green objects, they're essentially Python files or groups of Python files we're going to call in a sequential order. So I'm going to read in a table from Google BigQuery where my data is sitting. And the format that a prediction engine needs is it really needs 1 line per user if I'm making predictions on users. If I'm making prediction on accounts that'll convert, then it would be 1 line for that. If I'm making a prediction on an image object, it would be 1 line essentially for an image. So we need to aggregate our data. We might need to sum the total file size across all events that were uploads. Maybe that's relevant. Maybe we want to count the number of times the user has edited a clip. So we would need to run a SQL function or a Python function to count that up. And so what I wanted to do, I think might be a first in Zoom. You guys will be my guinea pigs here. I have no idea how it will go. But what I want you to do is we're going to pretend that we're the data to get a better sense of how this works. So if your first name starts with an A, B, C, D, E, or F, I want you to click the clapping icon right now under reactions. So we got Caitlin and Ashish. So you guys, as your claps come up here, you're going to be the group of historical users that did wind up purchasing. So what I want you to do when I reference your group, we're going to keep you awake here. Please, do the clap icon when I reference the group that buys. If your first name starts with G through L, I want you to find the crying icon on the reactions and please click that now. So I can see John Wang is crying, and he and others are crying because you guys did not wind up buying WeVideo. Same thing. If I mention your group during the presentation, please hit that icon. Next, if your name starts with M through R, I want you to hit the party icon. You are the group we're going to predict. We don't know whether you're going to buy or not. I kind of feel like we're alive here with the Zoom. This is going better than a lot of the meetings that I'm in. It's perfectly quiet all the time. And then if your first name starts with S through Z, I want you to find, I guess he's doing like a oh my face. If you can click that icon. And that group is going to be the holdout group. And I'll explain that. And so what happens is we go through these different scheduled processes. And in this pre-process step, we're going to split out the data. So the prediction group is not going to be in this data set. And then we have this holdout group, the oh my group that I just mentioned. So hopefully we're seeing some icons pop up from that group. We're going to take a piece of the historical data, hold it out, and we're not going to use it to train the mathematical models. We're going to use it to test the mathematical models. So it's never seen this data set before. So what happens is we use both the group that did buy and the group that did not buy. It goes into the mathematical model. Each model produces what's called a classification report. That classification report is basically a bunch of measures of accuracy. So how well is that model doing the predictions? And the way it does that is we compare the holdout group, where I know in the holdout group whether you bought or you didn't buy. But when we run you through the prediction engine, it's going to predict. And we're going to look at the data and say, how many times did we predict that that user bought? And we look at the holdout data to see, did they actually buy? How does that compare? And so each time there's a mismatch, right, our accuracy is going to decline. How many times did I predict somebody who was not going to buy? I said they were going to buy. And I need to choose how I'm going to define success and which one of the models is doing the best job at doing that. So that's a classification report. Finally, I have the models essentially that I want to use. And this is the process we use. Again, another 6 or so, looks like maybe 8 Google Cloud functions, or what do they call them? Services that I need to use in order to actually take my prediction group. Those are my party icons. Should be seeing a couple of, there we go. So you guys are awake. We take that prediction group and we're going to send that through the predictions using these processes here. And I have another job in yellow that needs to pull those predictions out of the BigQuery database and send them to my in-app messaging systems and my email systems and systems of record. So I outlined all these different services, and some of you may be thinking, okay, this is maybe a lot to do. And in fact, there might be many reasons that your company is not actually ready for machine learning. And the first reason that I would say you should wait on machine learning and AI is if you really don't know your business and your product well enough yet. And so what do I mean by that? Has a company and you as a product manager actually taken the time to identify whether there's a product market fit? And, you know, I would posit that people jump into AI and machine learning hoping for having these giant expectations about how it's going to revolutionize the business, when actually it tends to be an optimization on the business. And if you haven't really looked to see who's buying and how does that match up with who you're trying to target, and you haven't looked at the product level, what is the attach rate? Are you getting 80% of your users to use that primary function? Let's say we're talking about an app, primary function in your app. Are you getting 50% of them to return on a regular basis? And are people telling others, is your business growing organically? And I would argue that if you haven't looked into these and identified where the issues are, there is so much low-hanging fruit right here that if you add AI to it, it's just going to fall through these items if you haven't taken care of this first. And similarly, if you haven't looked at your primary funnels, your purchasing funnels, your sign-up funnels, are people getting to that first moment of value? If you're a person who's more on the back end side and working with sales systems, where in that sales process are people falling out? Again, the AI is not going to help you people are just going to fall through this leaky bucket. And the final item here in knowing your business is something that I think most product managers understand, those first two slides there. But what I've seen in my experience is a kind of a fear almost in actually talking to customers and getting that qualitative feedback. We've gotten trained now to pull our data straight from our data sources. And if you haven't identified from us on a customer interview today, it's just fascinating with our UX team and understanding the barriers to their use in their own words, the barriers to them paying if you have a lot of customers in Europe or India and you're not supporting your payment methods, competitive threats. If I'm going to push Ring Central on somebody who already has Slack, and I'm pushing our messaging feature, it's just not going to go anywhere. We should really be identifying what would help them succeed. And then finally, this is really the piece that I think a lot of product managers miss, is understanding how customers talk about what they value. Not talking about our features and testing our features, but what are they trying to accomplish? Where do they apply that value versus things that are just random ideas? And what language do they use so that you can mimic that in your apps and marketing content? The second reason you might not be ready for machine learning yet is you haven't taken care of your low-hanging fruit. I was at a conference, first live conference I had been in many years now, and there was an email conference next door, and they had told me that I was right, and HubSpot's recent report had talked about that email has a 1% click-through rate. So 1% of the people who get that email are actually going to do that call to action that you were hoping they would and get back into your app or service. On the flip side, push notifications and text messaging is shown that 90% of people respond to that within an hour. So if you have not enabled your push notification strategy or put that together yet, you're missing. Reforge would claim you can get about a 15% boost in re-engagement just from doing that alone. On the far right side, I'm showing more of like back-end process. So if you imagine your sales group is trying to upsell or renew subscriptions, and they come to the end of the year and they have no idea that the customer is unhappy, or no idea that the customer wasn't really using in the last 3 to 6 months, then they're wasting their time, right? And for them, it's frequently about finding the right opportunities. So getting the data, setting up these business processes and communication methods in advance, let's say, is a big low-hanging fruit. And the last one in this section really falls on us in product management and those who support us in email communications, push notifications, like engagement lifecycle marketing people, is making sure that we have more than an onboarding flow. Do we have, what happens after that first 7 days, that first 30 days? What are we actually doing to bring people back into the app that isn't just advertising to them? Also, what are we doing within the product itself? Have we enabled those hooks for marketing to communicate with them, or for us to nudge people in the right direction? And so one of the problems we found in the WeVideo machine learning project was that we didn't have these pieces in place. So for example, if I found out that somebody's highly likely to buy if I gave them a discount, well, I don't actually have a spot in the product where I can pop something up and say, here's your discount. You logged in 3 times, but you haven't purchased yet. Or even highlight, this is, out of those 4 plans, this is the plan for you. We didn't build any of that. So when we got to the end of the project, we didn't have nearly the pieces that we had hoped to influence the customer in hopefully the healthier direction. The third reason you might not be ready is you haven't gotten good at moving data fast. One of the hopes from the marketing department in kicking off this project was that they would be able to message people when they're trying to make buying decisions. And frequently that's in actually the first session. So now you might be talking about getting data to systems in the first 30 minutes, 15 minutes, hour, I don't know. But it was taking us 2 hours to aggregate the information, learn about the customer, run it through the prediction model, and send it back into these different systems like Intercom was one of our systems inside to communicate with customers. And so it's just too short of a turnaround. Another problem with moving the data is knowing what to say to people. So what I want as a mental exercise here, so if we take the clappers, the people who bought, if you can click your reactions again, you're probably like, oh shoot, it's making me do something again. All right. And now the people who did not buy, you're the crying icon people. If you could click yours. And what I want you to imagine is those of you who bought, I want you to imagine you're going to convince the non-buyers that they should purchase. And you're going to convince them of what plan to purchase. And what's probably going through your guys' mind is, I have no idea what I should be telling them, really. And we ran into this same problem. We managed to push predictions into each one of these communication systems. And then marketing realized, all I have is a score. You have a 60% chance of buying, but I don't know whether, should I be offering you a discount? Should I be, maybe you're low on the prediction scale. Should I be getting you customer support, sending you to our support site? Should I be nudging you to use some of our premium features? So I would argue that we need to get data into our apps and our systems of record that help them create those rules and give them more knowledge about the user, or maybe make predictions that predict what's the next best action for this customer and be more specific. Reason number 4 you might not be ready is pretty esoteric. If you only have hundreds of customers, it's a smaller scale, more service operation. You're probably not going to have enough data to be useful. These engines really prefer thousands and millions of records. And it's best to have, just as a general rule of thumb, 6 months of data. So if you're thinking about implementing a project like this, you want to start getting your data house in order. And that also means augmenting your data. Every place that I've been, I've actually found this kind of categorical data to be very predictive of what I should be telling a customer next. Imagine you've got a low net promoter score, you're probably not going to buy our software, right? But additionally, these other items here, and it's interesting that we talked about, I don't know if all of you were here when we talked about Hightail and Mike Trigg's new book, but some of these items were very relevant to the file transfer software as a service company that I worked at, Usendit and Hightail, and identifying what types of people are more likely to buy versus others. The last reason you might not be ready is you don't have the right people in place. And I mentioned that there's a whole different cycle that we typically don't show in our crisp DM model of data science. And this is everything that happens after you've created this amazing predictive analytics model and you've actually got to productionalize it, which isn't easy, it requires all these different people to handle the next piece. And those pieces are, you need a data engineer to continuously provide a pipeline of data to the prediction engine, and as well to train the model in the first place, as things change over time. And pipelines go down. Like, you can't just create this or have your developers create all of this and say, hey, we're done, we created a prediction model, right? These are live systems that are running, and data pipelines fail all the time and need a proper person to keep that moving and fix problems that happen along the way. We actually had this problem, and without having a data engineering team, and while it might sound like, gosh, we should have known all these issues ahead of time, we did know many of these issues. There were other reasons we needed to create a prediction model at that point in time. But not having a data engineering team, when values started coming through that we were not expecting, like null values in certain columns, the entire pipeline broke down within 1 month of executing the project. You'll need software engineers to hook this into your app and CRM systems. You'll need a machine learning engineer or team to run all these Google Cloud services, because guess what? They're not perfect either. They might go down. There's a Log4j security incident that happened, I think it was last year, and they'll need to update things on the Google Cloud side or Amazon side. Machine learning engineers are also used to optimize. This is a production model that's running. So if it's running too long after a while, it might be costing you a lot of money, or perhaps it's no longer that accurate. You know, if you remember that classification report, they'll be monitoring this and adjusting the models as they go. And then finally, you need a data scientist ongoing, because your data is changing. At RingCentral, we're publishing, gosh, I don't know, it's multiple times a quarter, hundreds of things are changing. So you need data scientists to take that into effect. If you got a new feature that your model doesn't know anything about, then you're not able to use the power of that in your predictions. So these were the 5 reasons you might not be ready. And I didn't want to be a downer about this. So we're going to flip it on its head, kind of Stranger Things style, I suppose. So how would you be ready for machine learning? You really need to start with analysts, not data scientists. We need to build out our business processes and our product hooks before getting started. Get good at have your team get good at moving data fast. So if that's all going to be done by your software engineering team, then they need to learn how to build structures that can retrieve and write data quickly and make it available to all the different platforms. Start augmenting your data and hire the right people. So I'm coming to the end here, and it probably sounds like this is a whole lot of work. And if I learned anything from high school, whenever you come across a whole lot of work, what should you do? That's right, cheat. Okay, well, maybe not in high school, those of you who have high schoolers, but I'm going to show you how to cheat and get there faster. The first way is there's this technology called AutoML. And the idea here is, if you have data engineering and you can get the data in the right format and get it into a table in Amazon Redshift or BigQuery or S3, then it will just read through that. It will train itself. It will pick the right models itself. It will make it available for predictions through an API. So you won't need any data scientist theoretically at all. I wish that was completely true, but they're moving in that direction. And it's one of the reasons that I was excited about going fully cloud for this. Another way to cheat your way through is through AI models that are already trained. So these are things like object detection in images. In this case, if I have an image or a video, all I really need to do is point the cloud service towards the files in S3, and it will provide some parameters, and it will start feeding back the information I need. Obviously not quite that simple. Here's an example from Amazon. It's called Amazon Recognition. A few of the things they do out of the box, you literally just call this this particular service. Again, you'll probably want machine learning engineers to monitor and make sure that this service keeps running and is doing what it's supposed to and still giving you good results. But we can identify text, we can identify specific faces when scenes change in videos, and so on and so forth. Some really cool, this is what I would classify more as AI than machine learning that I was talking about much of the time. This is from Google Cloud's page. Similarly, they have image and video APIs out of the gate. They've got some really interesting stuff around text, speech to text like Siri, sentiment analysis if you're involved with voice of the customer. We're doing a project right now in RingCentral, taking in all their feedback and trying to aggregate how many new feature requests come through and what, how many are video related, how many are related to our phone systems, but even deeper than that as what feature are they asking for. And that's actually rather interesting. It ports into Haha and Jira, where we can count up all the votes. We can also count up the MRR associated with those topics. And that happens through one of these technologies. And then conversational experiences and chatbots and translations. So little confusing that Google, I mentioned that the terms AI and ML are now really used interchangeably. Well, AutoML, Google has branded everything they do as AutoML. Everything they do is AI as well, and it kind of confuses, but this is what I'm calling pre-trained AI. And then the last way that you could cheat your way to machine learning is if you do have a data scientist, they can actually run very simple models called decision trees. And these are essentially rules. So this example from Towards Data Science is actually using the Titanic data set and predicting whether somebody is going to live or die from the accident there. And so it's saying if your sex is male and you're over the age of 9.5, then you're 61% likely to have died in that accident. And the reason why I bring this up is you can literally just take these rules and build these into your systems and not have to productionalize and go through all that automation work. The last thing I threw this in is just kind of a bonus. If you don't have any data science people, you can still do something. It's not data science or machine learning, but you literally can take your data and have an analyst or yourself look at it and look at how often an item is represented in your data set. So let's say we're predicting fraud, or maybe we're predicting that example of cancer or not. When we see how often does drinking pure radiated metal affect whether you're going to have cancer or not, you can count up how often you show up in the cancer group versus not, and use something called the phi coefficient. This is just a statistics thing that you can do it in Excel. And you get a sense of how important each one of these features is individually to the thing that you're trying to predict. So I'm hoping that you gain some knowledge there, and we'll talk more about it. Hoping to answer any questions that you might have or things that you wanted to discuss about AI and machine learning here. So Tom, were there any questions in the chat
So
first?
didn't get any just yet, although there might be some more coming shortly.
And it looks like Jim has a question.
Go ahead, Jim.
Hi, interesting talk. It seems like one of the biggest problems you probably run into is that people leap from the problem space to the solution space without having characterized the problem. In other words, what are we trying to gain from this? They just seem to be wanting to jump right in and do it because it's cool or everybody else is doing it or because they think it'll solve some problem, but they haven't really characterized the problem. Is that an accurate characterization?
Yeah, I guess along those lines, I have seen a couple things. I have seen, executives read TechCrunch. They talk to their peers as well, and it seems like, as Tom mentioned, everybody's trying to sprinkle AI dust on it before knowing what's involved there. But I would say it also, I've seen it places like Electronic Arts where we had enormous data science groups, but they were removed from the business people. And so they were creating great things, but really frustrated that 90% of their work never got used. Recently, I've been really advocating for data scientists to be embedded with the product management and product marketing meetings so they understand the challenges that those groups are trying to tackle at that moment. But I'm sure some of you probably picked up that some of the problems are project management, really, right? Identifying the specs for the entire project all the way through. And then some of it, I think, is just more the nature of companies. There's a lot we have to do as product managers before it really makes sense to do AI. And just digging down into the standard growth loop things, the onboarding funnels, product market fit analysis, and just making sure that our companies are mature enough to move this data around.
Thanks.
So thanks, Jim.
Do you kind of circling back to the executives that there's some folks that have got fairly deep experience with AI, but we also have they may be outnumbered by folks whose experience with AI is limited to watching George Lucas films and being able to chat with a robot and say, find me this, or the other big sci-fi franchise, Star Trek, where somebody yells, computer, tell me the answer to something or another. And it resembles, Alexa, and it resembles some of the other things, but we're miles away from general AI. And so I'm wondering if you have any good resources for kind of getting the non-AI, non-data science folks that are involved with the business to understand what's a good what's a good machine learning problem look like, and what are the prerequisites. Like, there's no training data set for this, so you can't just say, tell me what the next big stock winner is going to be next week. Why can't that be solved with just asking Siri today? And so there's a lot of folks that find themselves in that scenario. I wonder if you have any good, simple infographic resources or 15-minute YouTube videos that you might recommend.
I've actually never been asked that question in that way. And being on the technical side, I spend most of my time on, hey, what new model is out there and what's good and what isn't. I guess I don't have specific resources I can point us to right now on that. Maybe what I can say is verbally what I'm seeing is chatbots are getting better. And these are some, there's some out of the box things that we can already use there. And you just kind of set up some rules and look for keywords. It's definitely not perfect, right? Those of you that have interacted with them, every, homepage is trying to sell you something. But I am finding that you can get someone to where they need to go to the resource if you really work on the rules and think through that problem carefully. Things like sentiment analysis, I'm still not a giant fan of, where it looks at, say, a Twitter post and tries to figure out whether it's positive or negative. I feel like they've been trying for over 10 years now and just still hasn't picked up the nuance.
Especially sarcasm.
Yeah, sarcasm.
Yeah, I definitely have a problem with that. But the speech to text is where a lot of work is being done. I see that, and the transcriptions that I showed in Ring Central, even if you don't do AI to try and summarize, if you just want to transcribe something that's said, that's getting pretty good. I'd say that's 80% of the way there. And then anything that Amazon or Google needs to run their own business, that's something that I would say a business could be ready to implement if they have the right resources within the company, because obviously they're putting millions or billions of dollars in those things for their own purposes. So any of that Amazon recognition type is ready for prime time. Does that help?
Yeah, somewhat. I see Anna, Ray, you've got your hand up. So if you want to unmute and share your question.
Thank you, Tom. Ryan, a great demonstration of the application applying AI. I'm trying to find out what is the impact of introducing AI in this, in the business before and after, because it takes a lot of money and a lot of resources. Was there a baseline from where you started and the impact that you have seen?
Yeah. So the phases of the project were really, let's understand who buys and who doesn't. Let's then productionalize this. So now we have these mathematical models that might be beyond our understanding. It's just spitting out the data. Okay, let's now do let's do our sprints so that we can move those predictions into these different systems and make them available. And then the idea, of course, was that we're then going to get engineering resources and move this through product to start hooking that up to the product itself and making changes. And then the last piece is the part that I tend to like, being in analytics, is doing A/B testing. So turning on those predictions for some people and not for others. As an example, should we give discounts to people who are, 50% likely to buy? Should we give discounts to people who are 10% likely to buy? Those people probably aren't going to. So testing out even where in the spectrum of predictions is optimum. But my recommendation is to definitely start the project from the beginning and saying, here's my baseline. Here's how much lift I think we can get in this metric, if it's conversion or engagement. And then run that A/B test, compare to our hypotheses and what we think is acceptable. But unfortunately, if you're going to productionalize and automate something all the way through, you're talking 6 months just to get the predictions, and however many months, maybe 3 to 6 months to get that fully into all the systems and running, where you can even start testing which channels work and which don't. So that's why I kind of was hoping that some of the cheats help you get there a little faster. Maybe you don't need to productionalize it yet. Maybe just learning the rules about what works and instrument that first, and then productionalize things to do cost savings later.
Thank you.
Excellent.
Yeah.
One kind of follow-up to that, wondering if there's any, there's the Chris DM model and some of the other models, wondering if there's a standard format for kind of AI business cases, back to Anna's point of trying to put things together. And I'm thinking, oh, we need to get a data scientist or a consultant in here. We need to, and then getting the benefit, and then here's the cost and here's the steps involved. But whether anybody's done anything to have a standard kind of AI pitch deck proposal of all right, here's the things you need to think about with the checklists, and here's my cost benefit analysis for investing in AI for my product?
Actually, that's a really great question, because we did use a partner that Google put us in touch with, and that was the primary reason that we ran this project, knowing that we might not have all the pieces together yet.
Mhm.
And in their proposal, they actually worked with my analytics team to find out what are the baselines, and then worked with myself to determine, okay, how much room do we have on, let's say we're talking about the conversion rate. So if your conversion rate in freemium products sometimes single digits, or 10, 15%, right? Where are you at? And how much do we think we can improve from there? So I am seeing that in the proposals that I get from these companies that want to handle it end to end for you. I would say, though, that where I would start is from the product managers or business experts, and especially people who have gone through Reforge training.
Mhm.
There's a lot of you familiar with that program. I think Reforge and Andrew Chen have done a very good job of benchmarking what does good and great look like for different product metrics. And that's what I'm using within RingCentral, is to say, hey, our attach rate to this feature is X. This is where I think we can get. And based on the features that each one of the product managers are proposing, I think we can get Y percentage, or what, or the product managers determining, we got 20 percentage points here, possible growth. We think we can get 3 to 5 out of this feature. And I see AI the same way. You got to take that same approach.
Makes sense. Anybody have any additional questions? I got one I'm saving up for the end. Going once, going twice. All right. So for final question, wondering if you wanted to share, and this is a question that you probably run across, anybody who's an expert in any kind of new technology that's out there. What do you find most exciting, or what excites you the most about the potential of AI rolling forward? Where do you see this? Where do you see this taking products in the product space?
For me, I'm very interested in what it's doing in transportation. I'm not so much thinking of the Tesla self-driving as I am thinking about train automation, trucking automation. We were talking about drones earlier. I have some drones. It's just amazing their capabilities right now. And actually being able to travel by drone, I think, is maybe more likely to happen before full self-driving happens, because there's almost nothing to hit in the sky, and you can arrange things to fly in unison, and cars and trains to fly in unison. On the product side, I think much of it's really going to happen, or what I'm excited about is offloading a lot of things that we're doing manually. So if you've got these big customer support teams overseas, or sales and implementation teams that are doing, just pointing people in the right direction, I think there's a lot of opportunity to use chatbots as they get better to handle those more obvious things. One project I'm thinking of doing as well is detecting people whose usage is starting to trail off, and bringing forward resources that they need. So that's a form of predictive analytics as well.
Excellent. I think that's quite a lot of promise rolling forward, and a lot of things to explore and problems to solve that way. So excellent.
Yeah. Well, I just wanted to thank you guys for your time. This is my first session with the Silicon Valley Product Managers Association. I'm hoping to come back some more, and I hope you learn not to crash your Ferrari Enzo.
It's like that's some impressive driving there.
That is some impressive. I do some driving myself. This is not me, but yeah, I'm hoping that you have a little more confidence in how to launch your own AI projects. And you're welcome to link with me on LinkedIn there. That's what scanning that QR code would do if you have other questions, or when you get to it in a few months, you say, Ryan, any advice? Please feel free to reach out.
And when you build your next whiz bang product that's going to change the AI world, you could afford one of these vehicles. So, all right, with that, that wraps up our July meeting. Thank you all for coming. This was good fun. Please remember to keep an eye on the website. We will be sending out an email for our August speaker. We're still getting the details nailed down on that. If you've got additional topics that you'd like to see covered, or speakers that you've heard that you think are fantastic, please send them our way. We're always looking to optimize our speaker events, and we look forward to August and the rest of summer, and hopefully at some point we'll get back to holding in-person events once, a little bit. We'll ease into that, I think, starting beginning of next year. So thank you all, and we will see you all in August. Stay tuned for details on that. And thanks again.